We're here at the CADFEM conference 2024 in Darmstadt, and it's an honor for me to do this interview with my guest, Mark Hindsbo. Mark, welcome.
Thank you.
How do you like this conference so far?
It's such a pleasure to be here. This is probably, I think, the largest gathering we have of simulation and engineering professionals in the world, and it's just exciting to be with so many different professionals from so many different businesses.
Yeah, for sure. Mark, in your speech, Simulation at the Speed of Thought, you talk about Ansys Discovery and the Ansys Live Solver. Can you give us a quick outline on what is the value of the technology for the engineers?
Yeah, so my title is kind of a riff of a Business at the Speed of Thought book, which was written by Bill Gates a while back when the internet came. So that's an old book by now, but I think some of the learnings in general for technology are the same, and that's what my speech is about. I think when technology becomes much more accessible than it was before, much faster and much cheaper, we typically see a big change. So we're here very close to where the Gutenberg press was invented, right about half an hour from here. And you went from it taking a year or at least a month for a monk to copy a book to being able to produce thousands of books a day. And that changed everything. It changed the educational system. It changed the accessibility of knowledge for the whole sort of middle class, if you want. And I think the same thing is happening with simulation today. That used to be the domain of an expert. Now, I believe that the expert's going to be there forever, but I think similar to other things like Excel or the Gutenberg press, we now have a solver that it's easy to use, for anyone. It is, speaking of at the speed of thought, if not in seconds, you get answers in minutes. So it's very fast and interactive. And it's something that's come down in a price range where everyone that can afford to buy a laptop today, have access to the technology. So I think we're similar to, that Gutenberg press, or say when we got spreadsheets on the computer and all of a sudden all of us could play with numbers in an interactive way. I think we're in the middle of seeing something similar for engineering.
What I have seen in the last releases, you also do some enhancements in view of collaboration of engineers working together.
Yes.
Can you tell us something about this?
Yeah, absolutely. So it is not all just about features, physics features, if you want, right? It is definitely also about workflows. We talked a lot about cloud transformation these last couple of years, right? And I think for those of us in simulation, we might say that that's equivalent to high performance computing because we get a lot of compute resources, and that's certainly true. But I think the other thing that both the cloud technology in general, and certainly with the pandemic coming in, is that it's taught us to work and collaborate in different ways, right? Our meetings are very different. The way we collaborate on a document or a PowerPoint slide or an Excel spreadsheet, right? They're all different. We collaborate with people in multiple time zones across the world. So we want the engineering tools to be the same. I should be able to go in and say, do a fluid simulation and then ask you, hey, I'm a little bit in doubt. Is this the right way to set it up? And you might be in Germany, I might be in the US, and then when you get up, you can take a look at my comment and answer me.
Yeah.
So we're trying to make the engineering tools, if you want, as collaborative as your spreadsheet or your word processor or your virtual meeting tool.
Exactly. Oriented on the actual collaboration within the companies.
And there's no doubt that engineering is a team sport. Right? I mean, there are things where I go out to the lab and I work alone. But in almost everything I do, I'm going to work with other people in a broader team that are responsible for other elements of whatever I'm designing. So just enhancing that collaboration across the globe, I think, is very important.
Mark, let me allow to ask you an additional question, because you mentioned that now we can collaborate, and engineer A can do a structure mechanics simulation, engineer B can do a fluid mechanics simulation, and electromagnetics. So you unify several disciplines in one single tool. Is it your plan or a vision that maybe someday Discovery displaces the other tools like mechanical or fluent or something like that? And is this pre-processing simulation tool for all disciplines. Is this a thing we can do?
So it's a good and cheeky question, and I like it. So thank you. No, that is not the vision. Short answer, no.
Oh.
So here's at least how I think about it. And sometimes, when you take your crystal ball and you try to say what's going to happen in 10 or 20 years, you might get it wrong. But based on what I know, I would say that we tend to be in the general design process very multidisciplinary. To your point, right? If I'm responsible for designing the braking system of a car, let's take that as an example, right? I'm certainly responsible for the structural integrity, making sure that it brakes in the right way, but I'm probably also responsible for the thermal properties and so on, right? And the material properties and the environmental footprint and so on. So as the person who's responsible for the entire system, right, I have to look at multiple disciplines. Now then, when I have to participate as part of a crash test of the overall car, I'm probably going to go to a specialist that sets that up. So I think the deeper you go in features, the more specialized we become. And we tend to see it certainly with all our joint customers, right? That you have these specialized people within structural, and then sort of within that, I'm doing crash test, or I'm doing fatigue, or I'm doing fluids and I'm doing some specific parts of fluids, or I'm electromagnetics and I'm doing antenna design, high frequency. So I think there's a general tool for the generalist, and I think the more and more you specialized, the more and more you will sort of segment out. And if I look at sort of the roadmap of discovery, we're aiming on that sort of, if you want, broad base. And then when I look at my peers that are responsible for flagship, like the level of depth that they do. And sometimes I cheekily say, as engineers, that we're equally smart. The surface area is the same. It's a question of where it is. You might have a specialist who is very narrow, but extremely deep, right?
Yeah,
very, very deep. And then as a generalist, I might be more broad, right? But then I might not have the level of depth that they do. But it's not like one's smarter than the other. It's just different focus areas and expertise.
Yeah, this is exactly my home territory. I'm sort of specialist for rubber modeling, damping and so on, very deep and so on.
And is every engineer going to get to that level? No, they're not, right? That's going to be your expertise.
Yeah, but I'm very curious from release to see the new features in Discovery. There are a lot of new possibilities, and I'm always happy to see that.
The other thing I might say, sorry, given that you asked me sort of a riffing on, so I would say probably for your expertise, right, looking into rubber, you're probably going to have some specialist tool that you know exactly how to set up for some very, very sophisticated analysis. But then you might have to do a thermal analysis or a CFD analysis, and you might use Discovery, right, in the areas where you're not the expert, right, but where you're the generalist, and then you use a different tool. And that's why for us, it's not just collaboration amongst engineers, but also collaboration amongst the tools, right? We should be able to go from tools to tools, from generalist tool to specialist tool and back again.
Yeah. I also see this situation that I'm curious to do a fluid dynamics simulation, although I'm a structure mechanics guy. So, but this leads me to the following questions. The possibility for engineers, structure mechanics engineers, to do also other kinds of simulations. What is the impact or the impact of this technology regarding processes, trainings, and so on, regarding engineers and the process?
I think there might be two comments I would sort of make on this, right? We're talking about general accessibility and so on. I think the same way that the fact that we now have spreadsheets, digital spreadsheets, that does not make a non-accountant person into an accountant. It just makes an accountant a better accountant, right? And I think the same way with these engineering tools we're doing. It's not like, we have the technical Hochschule next door, right? It's not like the value education all of a sudden became zero. You still need to be a good engineer. I just think it's a matter of the tools that are there today can make you much more productive. So what do I think the biggest impact is? I think the biggest impact is we will ask more questions. We will explore more. The thing I would really like to change, and if we talk about sort of vision, if you want, right? I think sometimes as engineers, we are trained not to ask so many questions because it's expensive to ask questions. If I have to do a physical test, that might take 6 months of time, might cost me €1 million, right? So I'm going to be very clear on what questions I want to get asked from that test. But that's narrowing down the design space. I want us to be able to open it up and maybe think a little bit more like the medical industry is doing. So they run a lot of simulated tests early on, like millions of different, and then they narrow them down very quickly. And then they know that human testing is expensive and takes time. So they'll only do a couple of compounds through that, right? But they have opened up and asked tons of questions. Yeah. So I think we as engineers have an opportunity to really open up and ask 10 times, 100 times, 1,000 times more questions than we did previously.
I completely agree with you. For me as an engineer, I always feel the following. For me, simulation enables me the understanding of the system.
Exactly.
And the actual results, whether the Von-Mises stress is 100 megapascal or 200 megapascal, doesn't matter at the end. Nope. So the understanding, the possibility to understand the system, this is the benefit from simulation to my understanding.
Now, at the end, it might matter if it's 100 megapascal or 200 But if you're saying, hey, I'm looking at a broad design space, and I want to understand which is better, and if I have a specific stress concentration here, can I do something to alleviate that? Then it doesn't matter, right? Yeah. Then you're exploring broadly. And then when you choose a couple of candidates, then you get specific and sophisticated.
And even more, if you understand your system with simulation, you know how you can achieve 100 megapascal, and it's not trial and error. You can make educated decisions. And this is, for me, the most important thing. Mark, something which, I think very often about, and I guess you too, I hope you do, or maybe you too.
We'll see.
Is the topic AI. I guess we are at the beginning of the AI century or age. Can you tell us what is your strategy when you think about discovery, enabling simulation for everybody, in combination with AI? What is your vision? Can you tell us something about this?
Yeah, so I would say I am very excited about AI in general. I actually teach a course about AI in the local university in Pittsburgh at Carnegie Mellon, where I am. But I also think we have to be careful, right? AI is just one set of algorithms, and it's really good for certain things, and there are other things it might not be as good at. So if I think about something like discovery, one of the toughest things in discovery is really finding out, all these questions. So let's say we are designing this brake system. Maybe I want to understand how have other people done brake systems? What are the best way to set it up? What are the materials? I think there's a great opportunity for AI to help capture this unstructured knowledge. And you can go out today and say, hey, what are the best practices for brake design, or what should I look at? And you'll actually get a fairly good answer. And then you can go into a simulation tool and start, setting things up. So I'm really excited about, especially what I would call it the user experience, and how AI can help make the user experience better. Now, people are also experimenting of having AI algorithms solve the equations. I am personally a little less enthusiastic about that because it's really sort of just a great sort of nonlinear matrix system, right? That you're training. You need tons of training data to be able to train it to predict something.
Training is always a big issue.
Whereas we actually have first order principle solvers, right, that can solve the problem based on knowledge of the physics, of all the laws of physics. And typically they will, in my experience at least, be faster and be more accurate and don't need all the training. That's not to say there aren't use cases. There are certainly use cases where you have a lot of data and you can easily train an AI. But if you're doing a new design, for instance, you have no data to train your AI with, right? And there I would say the traditional solver technology would be better. So I really view it as 1 + 1 = 3, right? if you have great solvers that can solve based on first principles, and you have AI that can help you give inspiration of how do I solve this, how do I set it up, what should I think about, what are the engineering characteristics, I think those things really work well together.
If I understand you correctly, then you think about in a direction like an AI-assisted model preparation. Is this something
like that? Yeah, exactly.
Because then, for a generalist or everybody can have his own expert in structure mechanics on his own shoulder, and enabling a very high sophisticated analysis. Yes?
I think so too. Yeah.
I would also think if this someday come true, this would be a groundbreaking innovation. Yeah.
But we already have examples where AI helps us. You know, you spoke about discovery, right? We've just put or cloud-enabled discovery as well, so you can do design of experiments and do tens of thousands of simulations in parallel using the cloud, right? You might want to know a little bit about how much is this going to cost me, right? How long is this going to take? That's an example of where we've trained an AI to kind of predict and give you an idea of before you press solve and you put thousands of dollars into the cloud, right? You know, what am I going to pay for this roughly? What's the benefit going to be out? That's a great example of an area where AI can help in the user experience.
You speak about a resource prediction.
Yeah, just as a small, stupid example if you want, but like it's all part of putting a user experience together.
Yeah,
right.
This is already also implemented in mechanical. There's also a functionality resource prediction, and this especially helps also companies who do engineering services to plan the costs and the effort of their simulation. I use this functionality quite often. Not only to estimate cost, but also I have this memory. And how many elements I can use for my mesh. That I use my hardware as best as possible.
And then you can go the step further to your point, right? Then you can have another AI algorithm that actually sets up that mesh for you, so you don't even have to do it yourself anymore. Maybe you just tweak it, but all this sort of basic setup has been done.
Thank you very much that we have you here, and I had the possibility to have this interview with you. And I wish you a very nice rest of the conference and a safe journey back home.
Well,
Mark?
Thank you very much. Thank you for having me here. It's been a great pleasure. Thank you for putting on this great conference. It's a privilege to be here. Thank you.